Hi, welcome back to Mr. Slover's Math. Today we're going to talk about solving systems of equations by substitution. So that is our target for the day. We have a warm-up to get us ready for that. You're going to state the three different solutions you can have when you graph a systems of linear equations. So there's one solution, meaning our two lines would intersect once. There is no solution, meaning our two lines are parallel and never intersect. And there are many solutions, or infinitely many solutions, where the two lines are the exact same. So any ordered pair that you pick that's on the line would make both true, both equations true. The second warm-up is asking you to solve each equation after you substitute in a given value. So there's two steps. Number one, you're going to plug in your given information, and then number two, you're going to solve. So it says x plus y equals 3 given x equals 2. So where I see an x, I'm going to plug in a 2. So 2 plus y equals 3. We've seen that before. This is, I think, the fourth time we've seen something like this semester. The new part is now I want you to solve for that unknown variable. So since I replaced the x with something, my unknown variable is the y. So I'm going to solve for y. I'm going to subtract 2 from both sides. Okay, 2 minus 2 over here reduces. That becomes a 0. I'm left with a y. And then 3 minus 2 becomes 1. So my answer is y equals 1. Letter B. 2x plus 3y equals 12, given y equals 0. So where I see a y, I'm going to plug in a 0. Everything else stays the same. So 2x plus 3, instead of a y, I'm plugging in, or I'm substituting in 0, equals 12. 2x plus 0 equals 12. Divide both sides by 2, and x equals 6. C and D are very similar, so you can work through those and check it out as you go. So that was the warm-up that's getting us ready for substitution. And that's what we're getting into today. You've substituted information in, I don't know, dozens of times in your math career. But now we're applying it to a systems of equations. So it's a little bit different. There's a little bit more to it than just replacing one letter with a number. So a strategy for solving systems of equations that includes solving one variable and using that solution to find the other is called substitution. So we've already seen graphing, where you graph your lines and then go from there. Today, we're not actually going to graph. We're going to be just doing substitution. So just like before, you had three different possible solution scenarios. One was one solution, one was infinitely many or many solutions, and one was no solution. The same three are true here, but we're not graphing it, so it's going to look a little bit different when we solve it algebraically. So when we get one solution, we'll have x equals a number. Okay, this is just a number sign because that number changes from problem to problem. Or it could say y equals just a number. Okay, and once again, the number is generic. It could be any number. But if I get something after I do the substitution and it's x equals number and y equals number, then I have one solution. I'm going to write it as an ordered pair. If after I do some substitution and I start to solve and I get, for example, 7 equals 7 or 3x equals 3x, if I get a true statement, then that means I have many solutions. That means the line, both equations are the same line. And then the last one. If after I do some substitution and I start solving, I get 5 equals 8 or 0 equals 13, neither of those are true statements. Okay, because they are false statements, it means I have no solution. It means those two lines are actually parallel. Okay, so that's what I'm going to be looking for as I do my substitution today. So this very first example, there's nothing for you to do. You're just watching and paying attention. So it says solve the systems of equations using substitution. I started with two equations. So these two equations right here. 5x plus 2y equals negative 4 and x equals 2y minus 8. I have one of my variables, one of my equations is solved for a variable, meaning this 5 has an x with it. so that variable is not solved for. This y has a 2 with it, variable is not solved for. The x has a coefficient of 1, and it's all by itself on the same side. There's nothing else on the equal side with it. Right? So that's what I mean by it's solved for. One of the variables is solved for. X equals the other stuff. Right? So because I have that, anywhere I see an x, I'm going to substitute in this information, and I circled it so I know what I'm substituting in. Think about a substitute teacher. You're replacing one thing with another. So because I'm replacing the x information, I'm not going to have the x in there anymore. I replaced it. I substituted it with 2y minus 8. And just like before, anytime I do any sort of substitution, I'm putting it in parentheses. So 5, and instead of an x, I have a 2y minus 8, and then plus 2y equals negative 4. That is the only thing that changed. Instead of an x, I have that. Everything else in that top equation stayed the exact same, and that's what's going to happen every single time. Anytime you do a substitution, all the rest of the information in that equation stays the same. The only thing changing is that one variable is replaced with whatever you're substituting. So now I want to solve. I want to distribute the 5. So I get 10y minus 40 plus 2y equals negative 4. The 10y and the 2y are like terms. I combine them. They're on the same side of the equal sign. 12y minus 40 equals negative 4. I add 40 to both sides, and then I divide by 12, and I got y was 3. Now, typically, this is where the problem ends, but not so in a systems of equations when we're solving using substitution. I have one of the variables. I still need to find the other variable. I need to solve for x. So after solving for y, I'm going to plug it in. Well, it doesn't matter which equation you plug it into. I would suggest the one that looks the easiest. The bottom equation looks the easiest. So I'm going to plug it in. X equals 2. Instead of a y, I'm plugging in 3. 2 times 3 minus 8. X equals 6 minus 8. And x equals negative 2. So I have a solution. I have x equals a number and y equals a number. That's what I had right here. X equals a number, y equals a number. You write it as an ordered pair. Mr. Slover, how do you know what order pair to write it? How do you know whether it's 3, negative 2 or negative 2, 3? Alphabetical order. X comes before y in the alphabet, so negative 2 goes first and then the 3. So your first example for substitution is already worked through. You did substitution twice. You did it right here, and then after you solved and got one of the variables, you did substitution again. So yeah, there are a few steps, and I took the time to type it out for you. There are 5 steps. Number 1, solve one of the equations for x or y. It doesn't matter which. Remember, solving for x or y means you have x equals, and then everything else is on the other side of the equal sign. X is all by itself. Or the y is all by itself. There's nothing else with it. So then it would be y equals and then all the other stuff. Step 2, you're going to plug the answer from step 1 into the other equation. Then you're going to solve. Then you're going to plug the answer from step 3 into one of the equations and solve for the remaining variable and write your solution. So there are 5 steps. The best way to get used to this is just practice. Remember, practice makes permanent. Now you're going to start doing the same steps over and over again. You're doing a lot of substitution. So step 1, solve one equation for x or y. Well, good news, it's already solved. Y equals 6x minus 11. Okay, that makes it pretty easy. Step 1, done. Step 2, I'm going to plug in that information. Where I see a y, I'm plugging in 6x minus 11. Everything else stays the same. Negative 2x minus 3 is still there in the exact same spot. Equal sign and the negative 7 are in the exact same spot. The only thing changing is what I put in parentheses, which was the y. I substituted in 6x minus 11 for y. Then I distributed a negative 3. So negative 3 times 6x is negative 18. Negative 3 times negative 11 is positive 33. I have some like terms. I'm going to subtract 33. Now make sure you do negative 7 minus 33. And I get negative 40. So negative 40 divided by negative 20 is going to give me 2. All right, so that was step 3. Solve for the variable. Step 4, plug the answer from step 3 into one of your equations. Doesn't matter which. Go with the easiest one. Top one looks easier. So y equals 6 times 2 minus 11. So 6 times 2 is 12. 12 minus 11 is 1. And then I write it as an ordered pair. Okay, so this was the first one where we actually had to work through everything together. Once again, the only way for you to get better at this is just to practice. There are 2 more for you to practice. Here is your steps again. So letter A is already solved for you for step 1. X equals and all of your stuff. You just plug it in. But when I look at letter B, it's not. I don't have an X or a Y all by itself. So if that's the case, you need to solve one of the equations. The top one looks easier to solve. It looks like X is almost all by itself. All I got to do is get rid of the positive 2y. So I just have to subtract 2y from both sides. So x equals negative 2y plus 6 is my new equation that I will be using. So anywhere I see an x in the bottom equation, I'm going to plug in a negative 2y plus 6. And then I go through the same steps as before. Okay, so the only thing different about letter B is now I had to do step 1. I had to solve one of the equations. Okay, in order to do that, you're looking for a variable that has a coefficient of 1, and then you're getting it by itself. So the x has a coefficient of 1. I'm going to get it by itself by subtracting the 2y. I want to get rid of the y term, so I'm going to subtract 2y from both sides and then solve. If you have questions, make sure you stop in and let me know. Today we focused on substitution, solving a systems of equations using substitution. Here's our 5 steps. You're going to do substitution twice most of the time. Okay, everything that we did today came up with a solution, came up with one solution. But remember, it doesn't always have to be like that. You could get a true statement, which means you have many solutions.